All right, clap your hands once if you can hear my voice. Yes. How did the warm up go? Yes, no, maybe so. Okay. So we had a half hour, right? We did 3 problems. This is the type of speed you should expect to be able to at least do problems. So if you didn't finish, you've got some work ahead of you to definitely practice on these problems, right? Do them over and over again. This first problem we've seen about 5 times. So this should be a familiar problem. This is one that shows up in interviews all the time, this concept. So you got to be able to bang this one out immediately, okay? But let's go over it. So it says, write a function that takes an array and returns the count occurrence of each element in the array. All right, so the first thing we got to do is what? Declare a function, all right? Okay. So we're going to say const, we'll say occurrence count, takes in an array, give the arrow because it's a function, and here we go. So what is the return that we're trying to give back? What data structure?
Object.
An object with the counts, yes? So we don't currently have an object, so what's something we could deduce from that? We have to create one, right? So we're going to need one, we don't have one, so let's create one. So I'll say let counts, and I'll set that to an empty object. What's next? What's the next goal? What's the next milestone? It will.
Move to the array.
Yeah, so we're going to iterate through the array. So we can do that. We go array.forEach. So for every element, we want to call this callback function. So it takes in an element and is an anonymous function. So what needs to happen inside of this callback function? Marvin. A condition? And what's that condition?
Would be if inside of the object counts, if the element inside of that counts,
Yeah.
then you would do counts at element plus equal 1, because it will number how many times it sees that.
Okay.
Or else, if you only see it once, then counts at element equal 1.
Okay, sounds good. So to paraphrase what Marvin said, right, we're going to iterate through the array. We're going to key into our counts object and check the element if counts is contained in the element, right? If it has this key. If it has this key, it's going to have to be assigned to some numeric value other than 0, which will be a truthy variable. That's why we don't need to do any kind of comparison in our if, right? Our if statements are only checking to see if it is truthy inside. So it goes, okay, yeah, we've seen this before. Let's just increment the value of that key. Else, we're going to set this element into our counts as a key and assign its starting value to 1 because we've seen it now just one time. Questions on that so far? All right, cool. So at the very end of this, we'll return our counts so that we can return that object. Let's test our code. So we'll say console.log, and we'll call occurrence count, and I'll pass in some array that says 1, comma 1, comma 1, 2, 5, 5. And we're expecting to see 1 pointing to 3, 2 pointing to 1, and 5 pointing to 2. And we do. So it's working. Right? Do this problem literally 100 times. Like literally. Make it so you're so bored of this problem that you can explain it in your sleep to someone, right? My wife regularly complains that I talk to her about code in my sleep. So try to get your wives or husbands or family members to complain. No, she loves the code. Talk code to me, baby. All right. Right. Never going to happen in my dreams. All right. Write a function that takes in an array of nums and returns the sum of all the numbers. How do we do on this one? Yes, no, maybe. Okay. Right. So what's a good, what's the overarching plan? Rafid.
basically to create a function where each number is going to just add to the next number in the array.
Okay.
And I think the first, so we for each method that we use.
Okay. So there's a little bit of a paraphrase there, right? So let's try it out. So he said we need a function. We'll call this sum array. Takes in an array. Fat arrow. He said we're going to do an array dot for each.
Not yet.
Not yet. What's wrong?
Because you want to create a second variable and all that just to kind of define the variable, what's going to happen.
Okay.
Before adding all the numbers, you need to create a variable for that. So like the same variable sum equals 0.
Why 0?
Because when you start with 0 and that is the next number, it's not going to.
Okay, cool. So it's 0 plus anything is anything, yeah? So because of that, we want to start with our initial variable as a 0. What does this function return? What's the data type this whole thing's going to return? Will? No, I'm talking about sum array. What should this return? A number, yeah? Okay. Good. So for each, it's going to have some element. What do we want to do with the element? Just add it to the sum, right? It's like what we would dream about writing. Like, oh, let's just add it to the sum. If you can dream it, think it, dream it, want it, it's yours or something. I forget the line. It's Joseph and the Technicolor Dreamcoat. All right. Well, anyway, and then what do we need to do at the end? Let's return the sum. And let's, of course, test the code. So we'll say console.log. I wrote log like a bunch of times. We're going to say sum array, and let's pass in just sum array. That's 1, 2, 3, 4. We're expecting what back? No, 10. We're expecting 10 back. Right, 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. Cool. Not too bad. We're getting a lot of good for each practice on this. Write a function that takes in an array and returns the largest number in the array. So what's the overall approach we want to do for this one? Somebody new. Okay, but tell me more, Dave.
I'm going to set a variable equal to 0 to begin, and run for each, and then compare every number against the largest.
Okay, I'm into that. So I like most of that. So David said we're going to create a function that's called largest num that takes in an array, and he said we're going to need a variable called largest. So I should probably make that a let because we're going to be reassigning it. Let largest. He said to set it to 0, right? Why might I not want to set it to 0? Doug?
It might be 0.
Because it might be 0. Doug?
You might be comparing decimals or negative.
Yeah, what if I do console.log largest num, and this is my array. Oh, what would happen if I go ahead and do that? Yeah? It's going to show 0 as the largest, right? 0 is bigger than negative 4. Negative 4 there is actually the smallest number. So we're close, but different. All right, so we're going to iterate through our array, which David said. Let's say for each element, and we're going to do some comparison. So, well, we decide we don't like 0. What's a better thing for us to start with? Yeah, Karen? So we could do undefined. Totally feasible. If we do undefined, we're going to have to do one more if statement in here. That's like an extra check to see if it's undefined. Possible. Farah? Okay, so we could do negative infinity, because then we've got the smallest number in the world. So that's possible. What else could we do? Yeah, so for this one I would do array at index 0. The negative infinities are really good when you're trying to find second largest, because that way you don't have to worry about all this logic between the first two, which one is larger, not larger. But when we're only worrying about one number, we might as well just do array at 0. Right? That's going to ensure that we're starting with the first element. So then back to what David said, is he said we're going to need a condition. So that's just going to be array at if largest is smaller than our current element. Let's just assign largest, oh, that's from the music, to be the current element. Any other logic that needs to go in there? Not really, right? And at the end, we'll just return our largest. So we can run it through the test, and we got -1, which is happens to be the largest in that one. Yeah, Ashia.
What did you say when you about if we were working with another number, like say for example, if we had to find the second largest number?
Yeah. So if we had to find the second largest, we'd have to have like a largest and let second largest, right? And we'd have to assign something here. But we don't know if array at 1 is larger or array at 0 is larger. So we'd have to do some kind of decision making, like array at 0 greater than array at 1. Then we could do, it would be like array at 1, else array at 0. We'd have to do some kind of logic like that, and then do the same thing here, but
Is that a ternary?
that's a ternary, yes. And then this would be 0, otherwise 1. Right, so then we'd have to like do this logic, which is kind of messier than just writing negative infinity. That's why I wouldn't recommend that, but you could do that. That would also set you up on the right foot. Just waiting for her to finish the picture, and then I'm going to delete that code. Good? Okay, rock and roll. So for now, though, oops, just starting it at the 0th index is fair enough and clean. Okay, so hopefully those didn't feel too killer. If they did, you just need some more practice. Definitely make an extra effort to practice those types of problems. All right, a good place to practice those would be like in our array methods lab, and just going through code wars and finding problems that have to do with arrays and stuff. It's also good to practice with maps and filters and whatnot. And this brings us to today, right? We're going to learn my favorite array method. So I'm like super stoked. Coming down with a cold, and I was like really afraid it was going to be like Celine's cold where I lose my voice. But lucky for me, unlucky for you, I will keep my voice. So I'm so pumped up. Today we're going to learn about reduce. I'm going to write it on the board because I'm just excited. Right, so reduce. So I call reduce like king of the array methods. So why do I think reduce is the king of the array methods? Ooh, if this is for me, just tell them I'm in the middle of something. I'll call them back. Does anybody know why already? Yeah, Isaiah? Yeah, so essentially, you can use reduce for any of those things that we're doing. Like you might not always want to do it for each, but in some examples, you definitely could. But for map and filter and every and a lot of for eaches, you could just get away with using reduce. So it's a little bit more complicated, but not too killer. Let's just define it first. So reduce. So reduce is an array method. And so just like all array methods, it takes in a callback, right? But There's a couple little tricky things about it. So you can think of reduce as taking in 2 arguments. This is how we'll start thinking of it. Eventually we can think of it as an optional 2, but for sure 1. But so it takes in a callback, callbackify, takes in a callback and an initial start. All right, so that's one of the key differences. The second difference is going to be a little bit hard to conceptually visualize at first, but we're going to say the callback. So in regards to the callback, can anybody tell me a little bit about the callback for map and for each? What did it expect?
Function.
Yeah, the callback is a function, right? But what kind of arguments did it expect? Doug?
It expects it to be called on an array.
It expects an element. The callback expects an individual element, right? And an optional I for the index. This callback expects something called the accumulator and the element. So we're back to so same with the current element that we've always had, but also an accumulator. Also optional I, just like the other ones. So let me show you what I mean, yeah? I think that would be fair. So let's rewrite this. Oh, look at that. Callbackify somehow got up there. Interesting. I don't know what the heck's going on with that. Okay, so let's create a new function called occurrence count. Const occurrence count. And I'm going to call it reduce. This still takes in an array. Okay. So it's going to be a little tricky the first time, right? Because it's our very first time. And then it'll be a little less tricky the next time, and a little less tricky the next time. And then you'll be more on your own. It'll be a little bit more tricky again. It'll be okay. All right. So the first thing I'm going to demonstrate is, do you know how when we wanted to return the array that was filtered, or we wanted to return whatever the map gave us back? So for this problem, I'm going to return whatever reduce gives me back. Okay, because reduce can give back anything. So what does every give back? Dot every. What kind of array method does that give back? Karen? Gives back a Boolean. Filter, what's that give back? A shortened array, and what's in the array? The elements. It's the elements that came back truthy from the callback. Map, what's that give back? An array. How long is that array? Same length, right? What are the elements like? What? Transformed in some way, okay. And for each, what's that give back? Undefined, yeah, right? Good. Fast, Will. I got that eyebrow raise. He's like this. Will's like this. Undefined.
Yeah. I didn't tell you guys because you have taught me with that question like 5 times.
Even more, yeah. I'm good, yeah, good. Repetition. Kelvin? Repetition?
What?
Try?
What?
Try? Excellent. Okay, so we've got, anyway, reduce can give back all of those things. Okay, that's why, so reduce doesn't give back a set data type, right? It doesn't give back an array, it doesn't give back an object, it doesn't give back a Boolean, it doesn't give back a number, it doesn't give back a string, it actually gives back all of them, all right? So maybe I should have phrased that like it does give back, but it doesn't just give back, right? So I'm going to return whatever I'm getting back from this reduce. And I'm going to say array.reduce. Reduce takes in a callback function, yes? So right now I'm just going to write function. And what's the second argument that reduce takes in? Hang on, we'll go back down. Hang on. Reduce takes in a callback and an initial start. So on the very first problem here, what might be a good initial start? Oh, he there.
1.
So maybe, but I disagree. Okay, so what would you say is kind of the initial start here? Marvin?
It'll be counts.
Counts, which is what?
The object.
Is the object, right? It's this initial thing that we're building into, right? Okay. So with that in mind, my second argument is going to be an empty object. Okay? Pretty cool. Okay, so now I'm going to go back to the function here. This is our callback function. This is an anonymous function. It's going to have an arrow. Okay. Now let's look at this callback. What does this callback take in? Okay, and element. So this is what I'm going to write. Accumulator as an ACC and element. Okay. So let me tell you a little bit more about how reduce works. And I might need to draw it. Okay, so reduce works like this. So we have, the accumulator is assigned the value of the initial value. So I'm going to go like this to represent that. Right? We passed in an initial value as a second argument to reduce. That initial value becomes the starting value of the accumulator. All right, take a second to conceptualize it. So reduce. Took in a function, right? And an initial value. This initial value is the accumulator of this function. So if this is A, C, C, and L, that became the accumulator. So right now the accumulator is what? An empty object, right? Our initial value was an empty object. The accumulator, therefore, starts as an empty object. Okay, because we told it to do that. We said, we want this initial value to start as the accumulator. The accumulator travels through the reduce operations. Okay, so what does that mean? Whatever is returned from the last iteration. So let me write that down. Whatever is returned from the callback in the last iteration is the next iteration's accumulator. Whoa. What? What? Yeah. See? Yep. It is kind of like a running total. So whatever this reduce in our first, so initially our accumulator is an empty object. Our element is the first element in the array. Okay? Whatever this callback returns for this, so it's going to return something. This is the accumulator for the next callback call, for the second element. Okay, whatever that returns becomes the accumulator for the call for the third element of the array. So it's always one behind. Once it's gone through the entire array, reduce returns whatever the final accumulator was. So I think we'll make a little bit more sense if we go for it. Okay, so the logic in this should be pretty much the same. We can treat our accumulator as this counts object, right? Accumulator is just what I'm calling it because it's called, that position is called the accumulator. You can remember that it comes first because it's alphabetically first, right? A comes before L. That being said, I don't need that to be called accumulator because, like, if I wanted to be called counts object, like if I thought that made more sense, I could call it that. So if I wanted it to more closely mirror this, I could. So much so that I'm going to do that because I do want it to mirror this one. So I could say, I just called this counts. And I have the same logic. So if counts has the element, we're going to increment that value by 1. Else, we're going to set the element at the key into our counts and set that to the value of 1. What does this function return right now? What is this? What's our current callback return? Currently. If you don't see the word return, you should have an idea. Undefined, right? If you don't see the word return, it's returning undefined, yes? Okay, so if I run this, we'll see something. We'll learn a little bit. Occurrence count, I think I called it reduce, yeah? Okay. Let's save it. It's going to throw an error. And then you're going to tell me why. So here's the error. Cannot read property 1 of undefined. Why? Marvin, you want to take a stab? Yes. Yeah. Right? Because reduce right now is not returning anything, the accumulator for the next iteration is undefined. So it's trying to key into undefined, and it's throwing an error. So we have to return something so that we have something to accumulate, to continue moving forward. So at the very end of this, I should return what? Right, I should return counts because counts is what we need to keep carrying forward, right? We need to keep that object each time. So, okay, let's try that. I'm going to run it again, and we get our object that we want. Like magic. Okay, let's do another one. Let's do the next one on the list. So we have a sum array. Okay. So we'll call this const sum array reduce. Takes in an array. And what do we want to get back from this? Sum, which data type is that? Number. Will I be able to return a number from the reduce? Yes, so I'm going to return whatever I get back from reduce at the end of this one too. Return. Phone City. We're going to say array.reduce. And that's going to take in 2 arguments. What are the 2 arguments? The initial and what? Callback, right? So the first argument is what? Callback, right? So it's an anonymous function. And what's our second argument? What makes sense to be our second argument for this one? Sum. So I can't just write sum. Like if I just write the word sum, it will freak out and say sum is not a declared variable. 0, right? Because 0 is what we'll keep accumulating with, right? We're just using that value. Okay, cool. Well, we're going to have a term for it, but we can have a term for it here. So what are the 2 arguments that our callback takes in? What are the 2 arguments that our callback takes? Karen? Yeah, perfect. So Karen says the accumulator and the element, yes? For these purposes, does it make sense for me to call it accumulator, or is there a better variable name? Total, or if we look at our last problem, sum, right? But there's nothing wrong with total, right? There's also nothing wrong with accumulator. That position is called the accumulator. So a lot of the time you might just write accumulator because it's easy to remember. But because I'm trying to make a comparison to what we just wrote, I'm going to keep it with sum. Okay, so what did we need to do last time? Yeah, Doug? Yeah, we need to return and we need to update the sum, right? So I can say return sum plus equals our element. Okay, let's try it. So we'll do the sum array, and we'll say reduce. I'm going to save it, run it. Boom, we got our 10 again. So let's actually draw out how this is happening. Let's take a quick break from the board. So we've got our array. Say let array. And we have 1, 2, 3, 4. And we've got our array.reduce. This takes in our accumulator, so I'll call that our sum for now, and our element. And what's the second argument reduce takes? Oh, no, that was the first argument. Initial value, so for this one it was a 0. Okay, so let's, for now I'm actually going to call this accumulator. I think this will be easier for this part. Okay, so we can keep using the right terms. Okay, so our accumulator, okay, let me just wipe this first. I'm going to write it in blue. So our accumulator starts as what? In the first iteration. Here, I'll write the rest of the problem here. Okay. Yeah, so our accumulator is what?
0.
0. Okay. Our element is what? We should know this one. The first element in the array is it's a 1, right? It's the number 1. Are we okay? Okay. I know it's confusing, but if you try to guess the word ahead of me, like it will be more help. You will learn it better. Trust me. If not, you'll just be more passive in the lecture, and then you'll learn it a little less well. Okay. So this happens. It says accumulator equals plus equals our element, and it returns that accumulator. So the accumulator becomes what? 1. Right? We move on to our next element, which is 2. Okay. Accumulator plus equals L. What's accumulator become?
3.
Right? 3. And our next element becomes? 3. Right. Okay, great. We then go accumulator plus equals L. So our accumulator becomes? 6. And our element on the next iteration becomes? 4. Great. We return accumulator plus equals L. So 6 plus 4? 10. Any more elements? No? This is what gets returned. Right? That's how that's happening. That's the flow. Rough.
What happens at the return ACC if you didn't have a plus, if you just had an equal L?
I would be reassigning the value of accumulator, so we would probably just return the number 4 at the end. Good question. Okay, does that make sense? Okay, now Tetoka ati. Right, it's your turn. That's in Spanish class. I constantly used to play that tape. Did you have the same thing in Spanish class when you were in high school? I go Tetoka ati. It's your turn. That was the exact same voice. I swear to God. Okay. Now the goal is to write your new largest num reduce. Okay? We're going to do this. We're going to try this for the next 10 minutes. And we're going to try to write our own exact same thing we want from here. Okay? But you're going to use reduce. Oh, to the GitHub? Sure. There you go, come. You're welcome. All right, clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. Oh, Henry with the head clap. Cool. Okay. How did this one go? Yes, no, maybe so. A lot of pretty positives, though, overall. That's good. Let's do it. Let's go over it. So first thing we needed to do was declare our function just like our last one. So we said const largest num. Can't spell. Largest num. Reduce. By the way, I just got my 23andMe results in yesterday. So if anybody wants to talk about that later, then we totally can. Okay. I'm really European, by the way. Like I know I look different, but I'm 99.2% European. Okay. A lot less Polish than I thought. Anyway, okay. So then we're gonna say. So we're trying to get back what from this problem? Just a number, right? And will we be able to do that with reduce?
Yes.
Okay, so I can just return whatever reduce the value is to, right? Right, that's not always the case, right? Sometimes reduce is just taking us part of the way there. We're not just directly returning. And I'm going to make a quick example of that. I'll just say let biggest. I'm going to save whatever comes back for this one. And I'll say array.reduce. Reduce takes in how many arguments? 2. Which two are those? What's the first thing it takes in? That's the callback. What's the 2 things reduce takes in? Right, yeah, a function, aka callback, and an initial value. So I'm just going to do some kind of function here, and I'm going to pass in an initial value. What's a good initial value for this problem? Array at 0, right? David, I liked how clear and strong you said that. Okay, our callback itself, what are the 2 arguments it takes? Henry, come on, this is you. Yeah, which is also known as a, short for accumulator. That's hey, nothing wrong with it, right? Hey, he's taking a stab, right? Respect that. Accumulator, and for this one, we could just call it largest num. And then second argument is what? Is an element. Right. I just want to quickly, just don't let this change any of your ideas, but I just want to say like you also at this point could pass in an I if you needed to. Just like all of the other ones we learned, you could pass in an I. Right? Probably, it might not, you like usually don't have to do something like that, but let's say we're doing a lab problem today, and it was like multiply something by the index, maybe that's how you would do it. All right. Yeah. Okay, so then what do we need to do in here? For feed? My if, do I need an else? Okay, if, and what do I want to check? Okay, so if largest num is less than L, largest num is reassign the value of element. And anything else I need to do? Right, I got to return, otherwise my accumulator for the next iteration would be what? Undefined, thank you, who said that? See how? Nice. Okay, so we're going to return largest num. And let's... Oh, okay, great. Love it, thank you for the extra set of eyes. or 37 cents. Okay, let's try it. So we'll say largest num reduce, run it. Oops. Right, thank you. I was trying the new thing, right? I can also return biggest. That was you, Karen, right? Nice, quick eyes, I like it. And we get our -1. So we're in A-OK shape, yeah? Okay, so there's one more little caveat we should know about reduce. No big deal. Yeah, Henry?
I didn't, like, you know how you put 965 on, you said that biggest.
Yep,
That's fine.
that's fine. You just returned, right?
Yeah.
You only need to return. If I was writing this on my own for my own project, I probably would also have just returned. I only did it here so you could conceptually see that I don't need to return. I just need to capture whatever that reduce as a whole evaluates to. So I changed it up on this last one. Good question. Okay, so the one itsy bitsy teeny weeny tiny thing that you might see that can be different is, and I kind of mentioned it in the beginning, I said, for now I'm going to say that reduce takes in 2 arguments, right? And then I said, and I might also say that it's an optional 2 arguments and it really just takes in 1, right? Okay, so that initial value is optional. What? What? No, the accumulator is not optional. Here we go. Initial value is optional. So, what if I don't add an initial value? Right? That's what we're wondering. Okay. Arvin?
An initial value to like conceptualize like default value like how we had before.
As what?
You remember we did function problems and we set certain variables to default values?
Oh, yeah, you could think of it as that way, yeah. But I don't want to confuse it because that might not be more clear for everyone. Okay, what if I don't add an initial value? If you don't, the accumulator will automatically start as the first element in the array. And the first L will actually, if I could spell, be the second. What's that mean? Okay. In terms of this problem up here, yeah? We remember this problem, right? I hope so. We did it 10 minutes ago. Okay, so we had this 0 be our initial value, right? If I decide to drop this, based off of this definition, which may or not be perfectly clear, I have not reread it, what is our accumulator going to start as? Okay, good. So far, that's pretty clear. Good. Our accumulator starts as 1, and the element starts as what? R2. Okay, so everything else then remains the same. So it would go 1 plus 2 is 3, right? So our accumulator would become 3. Our current element would become what? 3, right? Because we're already at 2. 3 plus 3 is 6. That's our new accumulator value. Our element becomes
4.
4. 6 plus 4 is 10. And so, any more elements? No. And so we're left again with our 10. So for this one, you really didn't need to pass in an initial value because numbers being added up together, you don't really need an initial value. You might also not need an initial value for, say, one where you're trying to find the product, right? Because you're just multiplying all the numbers. You don't really need to start with the number 1 to do that. If I need to multiply 7 plus 4, I don't have to do 1 times 4 times 7. I can just do 4 times 7. I get 28 regardless, yeah? Hopefully. So, If you don't pass in the initial, just the first element becomes the accumulator, and that original element is actually the second element in the array, and it starts from there. That's the only difference. You're pretty much always welcome to use an initial value as well. And in a lot of problems, you will still need an initial value, right? The one where we were counting occurrences, where we started with an initial value as an empty object. This one, right? It would be impossible to not use this, right? Because we couldn't make our initial value start as the first element of the array, because then our accumulator would be literally the number 1, and it would just freak out. Ashia. For this one, it would have been 1. It would have been 1 plus 2. So the initial element becomes the accumulator, and the element that it starts to iterate on is the second element. For feed. Nice.
So with the fact that you had the initial value, it's doing 0 plus 1 plus 2.
That's right.
And when you don't have the initial value, it's still a 7.
Because it would just be 1 plus 2 plus 3 plus 4. Conceptually. Any other questions on that? I know that's like just a slight wrench. Don't let it taint your idea, right? You can still throw an initial value. It's just if you decide not to, your accumulator will automatically become the first element in the array, and your iterations will start on the second. That's it, right? That's not a disgustingly crazy idea. Just a small idea. Any other questions? Yeah, Maria. Yeah, so you would just pass in an I here. No, in addition to L. So here we can run this. Console.log I. What's time log? Time Lord, Doctor Who. Okay. And we will unlog this one. And we're expecting to see 0, 1, 2, 3, and then the final return of 10, yeah? If I drop to 0, still work, but we won't see the 0. We'll see that it starts at 1. That slash is because of a mistype. See here. So it just skips over. That's the only difference. Good question. Any other questions? All right, so you've been assigned a pair for the day. Somebody said that we don't have any labs, or I think that was Patrick. Fear not. Remember the array labs run we did? Yeah, so do that labs again, but this time only use reduce on numbers 1 through 11. The array methods lab, yeah. It's I will find the lab and Slack it. Or Jonathan, can you help me with that? You got it? Jonathan is going to find the array labs method and Slack it out. So with your pair, right, you just create another file. You don't have to like erase your old work or anything. And just do every problem with reduce. You can. I looked it through it to make sure. Okay? Isaiah. He's going to Slack it. Thank you.